Hello, this is the Tepid Coder. In this video I want to continue where I left off my previous C++ video where I was talking about how to make my own implementation of standard list. Yeah, in the previous video I had made functions like pop front, pop front and pop back, but I never actually showed them working, so I should probably do that. There's also some other silly things that I wanted to go over. Let's not need that anymore. Let's kind of go through the code here. I want to implement the erase function. I never actually got that working because it's kind of a difficult thing with the way we have classes nested right now to implement, but now's a good time to show it, so yeah. Okay, so the first thing I want to do is I want to show that you don't actually need the date time here before and after, right? Before I was doing this almost everywhere, showing the type before and the type after. So I'm going to remove that in all these cases, like right here. I thought I had another loop that was doing that. Is that it? I guess that's it. What else? I think I also want to show that the regular iterator works as well. Right now I've only done it for constant iterator, but let's actually show the regular iterator working. It's going to be just begin, this is going to be just end. Okay. Before each of these, let's actually see what we're doing. So, testing regular iterator. Okay. This one's going to be testing constant iterator. This one's going to be testing for each. Alright, list t for each. Okay, let's add some more stuff to the list too. I'm going to do list dot push back. Let's do 2, 3, 4. Let's do -1 here. Push that to the front. Now let's do this. List pop front. So we're going to delete that -1 off. And then list pop back. That's going to pop off the 4. So what should we have? We'll have 0 up to 3. Yeah, let's see if all that works or if I broke something. Actually, it's not going to work yet because I made that erase method. I need to implement that now. So if I do class iterator, I'm going to make a new method inside of this class. I'm going to say it's going to be node type k pointer underscore get node. I'm putting underscore there because I want to just show that this is a private method. I like to do that. So no except. Whenever I have like a private method for a class, I usually put an underscore before it. It's just my own convention. Anyway, something I'm going to have to do is expose this method to the class right here, list. In order to do that, I need to say that it can access its private members by calling it a friend class. So friend class list. That lets the iterator class know that its private methods are accessible by the list class. That's what friend class means. So that's pretty cool. I can kind of hide the implementation details of getting the node that I want to delete from the iterator class by doing this. So I'm going to say now list t iterator. Wait, what am I doing? Erase, not iterator. Okay, and inside of here, I want to say, first of all, it get node. There's an underscore in front of it. Okay, I'm going to say a node type t pointer called node equals, not null, call it n, equals this. Okay, once I do that, if in lp prev, so if there's a node before this one, then I'm going to say in lp prev lp next equals in lp next. So the node before this, if it exists, is going to have its next pointer point to the one after the node we're deleting. Okay, and if in lp next, if there's one after us, we're doing kind of the same thing. So, oops, in lp next, lp prev, so the pointer after us is now going to have its previous pointer point to the one before ours. lp prev. So now the list is reattached with us not being part of the list. We can just say delete n. So we're deleting the node now. So now I need to show a case where I'm actually deleting the node. But first, let's just show it working as it is, because it's getting kind of complex right now. standard C++, oops, equals C++ 20. Okay, what did I mess up? 157. Right, it's going to be also iterator T. Standard, it's not standard. Wait, why did I put standard there? Oh, jeez. That's funny. Okay, 247. 247. Probably wants the iterator also to be of type T. Okay, so 44. Invalid conversion from const to regular. Let's look at 44. Right, yeah. There's no reason to const qualify that. In fact, I can't because when I store it, it's not const qualified. Fair enough. So that was a bug from the last video that I just never got to. Okay, so we see 0, 1, 2, 3. The 4 I put in there and the -1 aren't in there. That worked again with the regular iterator. So we have for each, we have const iterator, and then we have regular iterator, which shows 0, 1, 2, 3. Oh, it's funny, it's showing the test I was doing from the last video. Testing not equals over and over again. And I only did that for the iterator class at first. So class, I'm in it right now. What am I doing? It's right here. That was kind of convenient. Okay, so clear that. There we go. That's looking a little better. So next thing I want to do here is I want to actually use erase. So I'm going to say main. And what one do I want to erase? 3 is the last one. Let's erase the 2. So if I start at 0, after these pop front and pop back, if I iterate 1 time, it'll be 1. 2 times will give me the 2. So I'm going to iterate 2 times and delete. Let's do that after the for each, though. So I'm going to say, start a new scope here. I'm going to say list int iterator type it equals list begin. I'm only allowing not standard iterators, but I'm only allowing list type iterators to be deleted. I'm not allowing for list t const iterator to be deleted, even though standard list does allow that. I've always found that to be a bit weird. Anyway, for, let's say size t sti equals 0, sti less than to 2, sti plus plus. So we're going from 0 to 1 to 2, right? This is going to run twice. So we're starting here, which is this. It'll be on 1, 2. Okay. T plus plus. Now I'm going to say list dot erase. We're going to erase the iterator. Now it's actually going to create that method, so we'll see if I coded it right. Looks like I didn't. Okay, undefined reference to get node. So let's look at that. Class iterator. Oh, I declared it, but I never actually defined it. Let's give it a body. This is going to return mNode. Okay. And let's see. We have 0, 1, 3, so I deleted the 2. That did work. Now let's test it again. I'm going to say list.erase. But this time, I want to test it by deleting just the first node of the list and just the last node of the list. So list.erase. I want to say list.begin. So I'm deleting the first, which will be the 0 is going to be gone now. Cannot bind. Okay, fine, fair enough. It wants to reference it. So I'll create a new scope again. I'm going to say list, type int, types iterator. Okay, it equals list.begin. Over here, we're just going to delete the iterator it. Let's try that. Okay, it looks like it was maybe unhappy there. Because I still see 0 in both cases. Right, yeah, it is unhappy. So here's the deal. I messed up that function because if I do list, t erase, what I need to do is I need to check to see this is the first node of the list. So if n equals m front, I kind of need to... No, I can still use that pointer just to see where it is. If it does equal that, then m front... How do I do this? I should store next. So I'm going to say node t next equals n lp next. Okay. Next. Yeah, okay. And then what I could do is I can also say node t prev equals n lp prev. That way if we delete the last node, we can do the same thing. So else if n equals m back, I'm going to say m back equals prev. Yeah, so if I delete the first element in the list, it's going to make the front point to the next element. If I delete the last element in the list, it's going to make the back point to the previous element. So that should keep the list intact. That's why it's important to do these tests for all the cases. You want to test one in the beginning, one in the middle, and one in the end. Okay, so that's working now. 1, 2, 3. We don't have 0 anymore. See, it was up here, but we deleted it. Now I'm going to test deleting the last node of the list. So let's go to main again. Okay. Do list int. Actually, I'm just going to copy this, I think. Okay. So 3. So I'll write right here. I'll do it over here. Test deleting the last element of the list. Okay. Yeah, so I deleted 3. That's fine. That's good. But if I was wrong about that, then it basically would have just kept trying to iterate to different points in memory, because the next pointer it would use pointed to something that doesn't exist anymore, and it would just give me garbage data when I access that structure. So I showed const iterator. I showed rig the iterator. I showed iterating in reverse, even though I didn't make a const reverse iterator and a reverse iterator. I just made a special thing for it. If I do anything different with this, I think at this point what I might want to do is maybe make it so that I can optimize the speed of iterating through the list by instead of making an iterator object to compare like this, which is really slow, like I showed over here in the last video, I'd make like an is done. And the other thing I might want to do, in fact, I might even just make like a not operator. Like I could say, you know, not CIT. I don't know. That's kind of silly. Well, anyway, the other thing I might do is I might make it so that allocation is quicker in the list. I can set some setting in the list that lets me allocate multiple nodes at a time, and I could just point them to different positions within the block that I allocated. And I just have to track exactly how many nodes are available at any given time. And that would be a bit quicker. But then I'd have to do is like placement new, and I'd have to delete from positions within those blocks, which is a little bit harder to manage. But it might be worthy time trade-off in some situations. And I could also make accessing a bit quicker. If I want to jump to a particular node inside the list, I could just iterate to the proper block and then linearly search by following the next pointers within that block. I think a standard deck probably does something similar to that. That's why it's quick for its random access compared to a list. Anyway, I'll probably do it in the next one. If you guys like this video and got something out of it, consider subscribing for more content like this. Give it a thumbs up. And if you have any questions, criticisms, suggestions, I'd love to hear those and at least read them. So please do post those. And if there's anything else in C++ you guys would like me to talk about, or something you feel like I haven't covered well, I'd like to know about that so I can perhaps fill in any gaps. I think that's about going to do it for this one, guys. I will catch you in the next one. Have a good day.